Hi, my name is Hyun Park. I'm the first author for the article entitled Selection and Reporting of Statistical Methods to Assess Reliability of a Diagnostic Test, Conformity to Recommended Methods in a Peer-Reviewed Journal. I'm very happy to introduce our work. Before I start, I want to express my immense gratitude to our co-authors and especially to corresponding author Seung Park. Let's start with the question, why reliability is important. Well, we often want to test an accuracy with an imaging biomarker, and let's say the value is around 1 at the initial and around 1.3 at the follow-up. Probably the difference between the average of measurement and true value has been increased. But what happens when the values on repeated scan vary like this? Then it will be very difficult to know the answer because the difference may have come from variability. And when the precision was poor, it is very difficult to guess where the true value goes. So for imaging biomarker, both accuracy and precision are important because not every biomarker is both accurate and precise, and some biomarker can be accurate but not precise, and some biomarkers can be not accurate but precise. An ideal quantitative imaging biomarker should be both accurate and precise, in other terms, valid and reliable. But compared to the guidelines of diagnostic accuracy studies START, guidelines of reliability and agreement studies are not familiar to us, including consensus-based standards for the selection of health measurement instrument (COSMIN), or guidelines for reporting reliability and agreement studies (GRAS). And indeed, lack of reporting reliability analysis was listed as one of top 10 statistical errors in submission to Radiology 2009. And we thought this suboptimal reporting reliability analysis in diagnostic research studies is come from the lack of familiarity of the investigators and peer reviewers to reliability analysis. So we thought reliability parameter is an important performance metric of a diagnostic test. So what we tried to do in this study was to evaluate the frequency of reporting a reliability analysis in diagnostic test accuracy studies. And also, for reliability analysis, we tried to assess how appropriately the statistical method for reliability analysis were selected and reported. We searched articles from KJR from January 2012 to December 2016, and we found 124 articles for DTA studies and 71 articles for reliability studies. The search terms for reliability studies included reproducibility, repeatability, agreement, precision, and reliability. After screening the full text articles, we included 99 articles for 63 DTA studies and 36 reliability studies. Before analysis, we first established terminology and recommended method for reliability analysis. So reliability can be called or cited as various terms like these. But reliability in this article will be used as a general umbrella term. First, we made distinction between reliability and agreement parameters, and second, we tried to distinguish reproducibility and repeatability settings based on these references. So let's say we measure body weights for 3 different persons, person 1, 2, 3, repeated for 5 different days. Within this person, we can measure agreement parameters. You can say within subject standard deviation was something, repeatability coefficient of body weight was something, Blend-Altman limits of agreement was something. This is parameter only within within subject variance considered. But let's say we calculate ICC, the interclass correlation coefficient for body weight. It is a reliability parameter, how well patients or persons can be distinguished from each other despite measurement errors. This is somewhat different from agreement parameters. So reliability is calculated like this. We consider measurement error, but what it determines was variability between study subjects. So both between subject and within subject variance considered. Like when you think of reliability parameters for person 1, you need to think of the variability between the person 2 or person 3. So again, agreement parameters expresses the exact range of difference, while reliability parameters is a scaled index and between subject variance is considered. So we can say the SD of tumor volume was something exact range, or we can say the overall reproducibility of measurement was good, with ranging from 0 to 1. Distinction between repeatability and reproducibility is rather simple. Repeatability is the same or similar conditions, measurements using the same procedure, same operators, or same location over a short period. We say a coffee break period. So this setting will be a repeatability setting. The reproducibility setting is somewhat different. It is kind of this, a rerunning of measurement in slightly different situations such as different locations, operators, and scanners. Based on these, we established recommended statistical method for analysis of reliability. For dichotomous or nominal data, kappa and proportion of agreement will be appropriate. For ordinal data, let's say grades, weighted kappa or ICC needs to be used. For continuous data, agreement parameters are seen as below, while reliability parameters is ICC and CCC when to explain the between subject variability. For 36 reliability studies, 4 independent reviewers worked as pair. Evaluation was conducted using a predetermined questionnaires via Google Forms. When there were disagreement between the two readers, biostatistician educated and finalized the evaluation. The questionnaires included the data type, which data type was it, whether they used the recommended statistical methods, and appropriate use interpretation of reliability or agreement parameters, and correct use of the terms reproducibility and repeatability. And additionally, when kappa was used, reporting a weighing method, when ICC was used, reporting of model and assumption were assessed. For 63 DTA studies, 9 independent editorial board members of the KJR assessed whether the study reported reliability along with accuracy. And the question was simple: if not assessed reliability, the editors judged it if it was deemed necessary. So these are results of reliability studies. Among 36 reliability studies, 5 were dichotomous nominal outcome, 15 were ordinal outcome, and 21 were continuous outcome with replications allowed. And use of recommended statistical methods, all of dichotomous and nominal data followed recommendation, while about half of ordinal data did not follow recommendation. They actually used the unweighted kappa for ordinal data. And one study from continuous data did not follow recommendation. For reporting weighing method for weighted kappa, or reporting of model for ICC, or reporting of assumption for ICC, majority of them lack details. For appropriate use and interpretation of reliability and agreement parameters, most of studies followed appropriate use, and they used correct meaning of reproducibility and repeatability among about 80% of them. These are examples of null or uncertain for use of recommended statistical methods. For this continuous outcome, they use Pearson's correlation coefficient, but this is wrong because it is neither reliability nor agreement parameters, and this is just correlation. And another example is they used grade for ordinal data, but they assess it with unweighted kappa statistics. Here's an example of inappropriate use and interpretation of reliability parameters. So what they measured was artificial luminal narrowing on using phantom on 1.5 Tesla and 3.0 Tesla, but they were proposed to measure measurement error, but what they used was an ICC, a reliability index. It is not helpful if one wants to know what specific range of measurement differences should be considered. Among 63 DTA studies, about 49.2% did not include a reliability analysis, though it was necessary, and others included reliability analysis or did not include, and it was not necessary. So in summary, approximately half of the DTA studies did not include a reliability analysis when it was deemed necessary, and most of the reliability studies seem to have selected the proper statistical methods for the analysis. But a small but notable fraction of studies imprecisely interpreted the reliability parameters, and the distinction between repeatability and reproducibility was not perfect. So there is a room for improvement. To improve describing details for weighing kappa method, you can use Metcalc to describe and choose which weighing method you want to use. And for ICC, you can use either SPSS or Metcalc to describe model. Raters for each subject were selected at random, or the same raters for all subjects, or type, which is consistency assumption or absolute agreement assumption. And what we noticed that the repeatability coefficient is a very important agreement index. It is often underutilized. We thought this is because there is a lack of user-friendly software to calculate this parameter, so we actually developed one via Asan Imaging Metrics, AICRO. So you can go to this website, datasharing.aicro.com/reliability. So when you go to this website, you can calculate your own repeatability coefficient, and you can download sample file here. It looks like this: repetition 1, repetition 2, repetition 3, and you can actually add on your repetition number. And what you need to do is just select file and upload it, and then press calculate. And within seconds, there will be results given within subject standard deviation, and within subject coefficient of variation and repeatability coefficient. So in conclusion, the quality of reporting the reliability analysis of a diagnostic test can be improved, and reporting the reliability of a test, thorough description, distinction of agreement parameters, differentiation of reproducibility and repeatability are important. And some of the tips discussed in this article, including the software tool to calculate the repeatability coefficient, may be helpful. I hope you enjoy our article, and I hope you try to use the repeatability coefficient via our software tool. Thank you for listening.